Let's analyze some functions.
I feel like we analyze a lot around here.
We do. That's a big thing in mathematics, actually in life in general.
What?
So
Say it isn't so.
So we're going to do the common logarithm, log of x, and the natural logarithm, which is log base e of x, and it would look very similar.
They look awfully similar.
Actually, like, is there a difference?
I don't see a difference.
All right.
But there's got to be one because those are different bases.
So it must have to do with, what do you think, maybe the rate at which they increase?
You know, it's quite possible the rate at which it increases.
I don't know.
The difference is.
I don't know. Or maybe it's a very, very small differences.
Yeah,
Who knows?
maybe so.
So
okay.
Domain for log of x.
It's going to go from 0 to infinity.
Right.
You cannot
because
include
look at the
either
x
one of those,
values.
right?
There's a vertical asymptote here at 0, and then it's going to the right, so 0 to infinity. The range
goes from negative infinity to positive infinity. Now, this is almost a trick question because when you look at it, it certainly doesn't look like it's going towards negative or
right.
towards positive infinity.
Right, but if we could keep going forever and ever and ever, it would continue to increase the whole time.
Right, the whole time. So
continuous?
Yes.
Okay.
Totally continuous on its domain.
So should I just put on its domain?
Yeah, that's fine. It also increases the whole time. Increasing behavior from negative infinity from 0 to infinity.
Positive infinity. Mm-hmm. Okay, bounded.
It is not.
No, because our range is from negative infinity to infinity. One of those has to not be there
right.
for it to be
bounded. They're both there.
Not bounded.
No extrema either because there's no maximum or minimum value with this since it continually increases.
Right. And so this, yeah, totally. Symmetry.
It's got no symmetry. It has a vertical asymptote at x equal 0.
Right.
But it doesn't have a horizontal one because it's not bounded.
Right.
Okay.
And then the end behavior.
It actually approaches infinity as x goes to positive infinity.
As x goes to positive infinity, it goes to infinity.
We can't really do negative infinity here because we don't approach negative infinity.
Oh, you're right. We can't, because look, it gets stuck.
Yeah.
We don't ever get towards negative infinity.
Yeah,
so that other limit, you could either write it and say it's undefined, or it does not exist, right. Or just, I guess, not write it.
Yeah, I mean, what we have written is fine. So, hey, guess what?
Is anything going to change?
There's nothing that's going to change, even though these are two different logarithms. They are still logarithms. They're bound by the same general rules,
right?
Which would include all of these. So we could just copy all of those answers, paste them all over there,
right?
And that's there's no need to write it all again. But sometimes in the teenage brain, there is a massive. Does that say samesies?
Yeah.
I like it. There is a difference between log x and natural log x, and there is not much of one.
There's not.
They're both logarithms.
It would be like we say there's not a lot of difference. If you actually are computing values, there is a difference.
There is a difference.
And you wouldn't want to use one instead of the
other.
Right.
If you're building a bridge and you need to use log 10 or a common log, please do that. Don't use the natural log.
Right. But, I mean...
But graph shape
is
behavior and all of that are...
So then we could look at this and say, whoa, what if we do a vertical shift, right? Or a vertical stretch, or what if we reflect this? And those are going to be similar transformation rules as to what we've already done.
Right.
So.
Righto. What are we doing today in